Okay, everyone, let's begin. Iman, Arish, spread them, please. Everyone, please put your phones away. They should not be on your tables. Table पे नहीं होने चाहिए. All right, children, let's start. We were doing trigonometry and we were done with a number of concepts. The most important of them was how we solve trigonometric equations. All right, so we learned how to solve trigonometric equations. There was one standard method for this. We said we'll do two things. We'll find the basic angle, right? Once we have found the basic angle, we use quadrants to figure out what angles are the solutions to that equation, right? That was one method that we did. That works for most equations you will get. But there was one exception, and that was if you end up getting a basic angle of 0 or 90 degrees, okay? Because then you have a problem. You will not have angles that fall in any of the quadrants. They will be on this x or the y-axis, so you can't really place them in any quadrant. So the quadrant method does not work in these cases. When is that going to happen? When you have one of these two cases. When sine theta or cos theta is equal to 1 or minus 1 or 0, right? Then you'll have that problem. You'll get angles which are either on the x-axis or on the y-axis. You'll have that problem. या फिर you have tan theta equals 0. That could also be one case. What you're going to do in this case is you're just going to check the multiples of 90 that fall in that interval. So if the interval is from 0 to 360 degrees, you check all multiples of 90 and see which of them satisfy that given equation. So you have cos theta equals minus 1, for instance, and you're given the interval 0 to 360. All you do is you check 0, 90, 180, 270, 360 and see if they satisfy or not. ठीक है, आपको ये चेक करने हैं. जो satisfy कर देंगे वो आप कहेंगे वो solutions हैं, otherwise they're not going to be the solutions. That's the standard method that we have for such questions. All right. ये हमने कल देखा था. We also looked at a few examples when we have radians. Radians में भी आप वही सब कुछ कर सकते हैं quadrants को use करके. So you should also be comfortable using radians there. This is what we did in the last couple of sessions. Now, before we can do a lot of questions from the worksheet that is uploaded, is it uploaded yet? Worksheet uploaded? You have some questions assigned from that as well? Has anyone started doing anything? कोई question start किया करना? नहीं, so you unanimously decided not to do anything? किसी ने भी एक ने भी नहीं किया? Okay. If you had tried, you would have figured out कि ज़्यादा questions आपसे होने भी नहीं थे अभी, because a lot of questions require use of some identities that we haven't covered yet. वो हम आज देखेंगे और आज के बाद फिर आप almost सारे questions उस worksheet से कर सकते हैं. Okay, it's going to be a short class today. We have already wasted like 30 minutes. We have 25 more minutes to go. इसमें हम वो दो identities देखते हैं जो आपको यूज करनी होगी वहां पे. We call these trigonometric identities. अच्छा ना, before we do this, what is an identity? Does everyone remember that? Identity क्या होती है? What's the difference between an equation and an identity? Partial fractions में किया था हमने? Yes? So if I have 2x plus 6 and 2 into x plus 3, these two are identical to each other because 2x plus 6 is just another way of writing 2 into x plus 3. Identity is something that is true for all values of x. True for all values of x. Equation, on the other hand, is only true for some specific values. So if you have 3x plus 5 equal to 1, This equation is only true when x equals, or let's say this was -1. This equation is only true when x equals -2. That's the only solution for this equation. Equation is only true for some specific values. It's not always true. Okay? And identity is true for all values of the variable. आप जो मर्जी x की value यहाँ पे input कर दें, the left hand side is always going to be equal to the right hand side in this case. All right? We have some trigonometric identities that we need to know about, and we're going to write down two identities here first, and then we'll briefly discuss where they come from. लेकिन हमें वो use करनी होगी to solve a number of different types of questions that we see there. First of all, we've got this one, sine square theta plus cos square theta. This thing is identical to 1. No matter what value of theta you input here, it's always equal to 1. Sine square theta plus cos square theta, this is always equal to 1. All right. This is one identity that we have. We have another one, which is tan theta identical to sine theta over cos theta. This is another relationship that we've got between these functions. Tan equals sine over cos. All right. Sine square theta plus cos square theta equals 1, or is identical to 1, and tan theta is identical to sine theta over cos theta. ये दो identities हैं जो हमें यहाँ पे use करनी होंगी. You'll be given both of them in the formula sheet as well, but once you've done some questions, you'll start remembering them as well. In paper 1, these are the only two identities that we do. All right, we'll do more when we do paper 3 trigonometry, and there'll be many more, but in paper 1, we only have these two. For now, these are the only ones that we worry about. Now, before we try to understand where they come from, it's important to understand some notation. Sine square theta is just a short form of sine theta whole square. Sine theta whole square जो होता है, इसको हम short form में इस तरह लिख देते हैं, sine square theta. Okay? Sine theta whole square is not the same as sine square theta square. It doesn't work like that. Sine is a function. Sine is a function that's applying on theta. सिर्फ sine के ऊपर आप इस तरह से square लिख देते हो. Essentially, इसकी जो actual form है, वो actually ये होती है. This is the proper mathematical way of writing this. Sine theta whole square. जब आप calculator में भी ये डालते हैं, तो आप इस तरह डालते हैं. Sine of angle and then whole square. This is just a short way of writing this because we need to write this down so many times. We want to get rid of the brackets and have some short form of writing that. उसके लिए हम sine square theta इस तरह लिख लेते हैं. ठीक है? So sine square theta is the same thing as sine theta का whole square. All right? इसी तरह से cos square theta, that's the same thing as cos theta whole square. And the same thing works for cube and power 4 as well. हम बाद में देखेंगे. We'll have higher powers as well. If you have sine raised to power 4 theta, that would be the same thing as sine theta whole raised to power 4. We've also seen this function before, sine inverse of theta. Sine inverse theta क्या होता है? If you have, let's say, sine or x equals, or sine x equals something, let's say 30 degrees. No, it can't be 30 degrees. Sine x equals 0.5, let's say. If you have to find the value of x, what do you you do sine inverse of 0.5. I should not use theta here, actually. It should be x, let's say. And let's write this as theta. Acha. Sin theta equals 0.5 अगर आपके पास, theta equals sine inverse of 0.5, right? This thing is a different function. It's a separate function. It's not sine x whole raised to power -1. ये दोनों different चीजें हैं. तो थोड़ा सा confusing होता है शुरू में. Should know this. These are not the same. Sine inverse of x and sine x का whole inverse, whole raised to power -1, they are not the same. जो positive powers में हम ऊपर ये short form use कर रहे हैं, -1 के साथ ये नहीं कर सकते. Sine inverse is a separate function. Sine of x whole raised to power -1 would actually be, this is actually 1 over sine x. And that's different from sine inverse of x. These are two different functions. Okay? Sine inverse is different and 1 over sine x is something different. So ये notation आपको बहुत clear होनी चाहिए. Sine square theta क्या होता है? Sine theta का whole square. Alright, that's where this is coming from. So we've got these two identities now. You will need to use them a lot of times. Let's quickly try to understand where they come from, and then we'll do at least one practice question before we end. Okay? First of all, we've got sine square theta plus cos square theta equals 1. Let's start with this. Sine square theta plus cos square theta identical to 1. Let's think about this first. How do we define sine? Sine theta is perpendicular over the hypotenuse. What about cos? Cos is base over hypotenuse. If you were to square them and add them, what happens? If you had to find sine square theta plus cos square theta, in fact, let me write it like this first. Sine square theta plus cos square theta, what does that mean? That's the same thing as saying sine theta ka whole square plus cos theta ka whole square. What's sine theta? Perpendicular over hypotenuse. You square this whole thing. And base over hypotenuse. And you square this thing as well. So we want to evaluate what sine square theta plus cos square theta is. In place of sine theta, we input perpendicular over hypotenuse. And in place of cos theta, we input base over hypotenuse. Now, what do we have in the numerator? We have perpendicular square plus base square. And the denominator is same. So the LCM is also going to be that, hypotenuse square. What is perpendicular square plus base square? That's hypotenuse square. Pythagoras. But perpendicular square plus base square is hypotenuse square. So in the numerator as well, you get hypotenuse square, and in the denominator, you've got hypotenuse square as well. Now they get cancelled, and you get 1 from that. No matter what the value of theta was there, it always equals 1. आपको 1 ही मिल जाता है. Does that make sense? ठीक है? That's one identity. Sine square theta plus cos square theta identical to 1. This will be given in the formula sheet. We'll have to use that. You'll have another one, that's tan theta identical to sine theta over cos theta. Now this one is simpler. Let's start with the right hand side in this case. What's sine theta over cos theta? Sine theta can be written as perpendicular over hypotenuse, and cos is base over hypotenuse. Hypotenuse and hypotenuse get cancelled. What do we get? Perpendicular over the base. What's perpendicular over base? That's tan theta. So sine over cos always equals tan theta. All right. This is the second identity that we've got. Okay, so if you understand the background, that's good. This is just for your own understanding or intuition. But you'll have these identities given in the formula sheet. The main thing is you need to be able to use them in different types of problems. वो भी हम देखेंगे. Let me summarize this now. The first one is sine square theta plus cos square theta identical to 1. And from this, we can also infer that sine square theta can be written as 1 minus cos square theta, and also cos square theta can be written as 1 minus sine square theta. We'll be using these two a lot to convert sine square to cos square and cos square to sine square, right? So in one equation, we might have both cos and sine. If we want to solve that equation, we would need to have a single function. So we can convert either sine to cos using this or cos to sine using this. Okay? You'll understand that better when we do some examples. And the second one is tan theta identical to sine theta over cos theta. There's one exception to this, and that is cos theta cannot be equal to 0. And that makes sense because if cos theta is 0, you'll have 0 in the denominator, and that makes this whole thing undefined. All right? So cos theta 0 nahi ho sakta. Apart from that, this identity is always true. Is that okay? Any problems? No? अब ये identities use करेंगे हम और different problems से apply करते हैं. We still have 12 minutes. There's a common error here. Just write that down here as well. Sine square theta plus cos square theta is equal to 1, is identical to 1, but it does not imply that sine theta plus cos theta is identical to 1. That's not true. Right? So a lot of people end up doing this sometimes कि sine theta की जगह पे वो लिख देते हैं 1 minus cos theta. That's incorrect. You can't do this. ये नहीं कर सकता. Sine square theta plus cos square theta equals 1, not this. Okay? If you were to take square root on both sides, you get 1 on the right, yes, but you can't simplify this. There's no way to simplify what you have on the left hand side. Powers ko khatam nahi kar sakte. There's a plus sign in the middle. You could only do that if there was a product here. Then you could get rid of these squares, but plus hai yahan pe, isko kuch nahi kar sakta. So this identity only works with squares, not single powers. Make sense? Okay, so that's pretty much it. Now you can do most questions from the worksheet. Let's start by doing a couple of questions today. We have some time for that. You have this worksheet uploaded already. You'll be getting printed copies of this on Friday as well, inshallah. Let me start with a relatively simpler problem. First, let's say 4. Question number 4 से start करता हूँ. All right, so we need to solve this equation. 3 sine square theta minus 2 cos theta minus 3 equals 0 for theta between 0 degrees and 180 degrees. So your final answer has to be within this interval, between 0 and 180. Now, let's write this equation down. We've got 3 sine square theta minus 2 cos theta minus 3 equals 0. Now, this is an equation in which we have two functions. We have sine and we've got cos. We can't solve this directly unless we can convert it to a single function first. Remember, we only know how to solve equations that look like this at the end. We have cos theta equal to something. We have tan equal to something. We can't have multiple functions. If you have multiple functions, you have to make them one somehow. You have to convert them to a single function first. We've got sine square and cos. How can we get one function from this? Non-admits people. Admits wale nahi. How can we get one function from this? Yes, Feroza. Okay, so let's start with that. So cos की जगह पे हम लिख सकते हैं 1 minus sine. Can we do that? Square. Okay, so square, but then we have to put square root there. Muniba. We just discussed single powers में वो identity नहीं apply होगी. Single powers में वो identity नहीं apply होगी. We can only do that on squares. So instead of converting cos to sine, we should be converting sine to cos. इसको हम cos square में convert कर सकते हैं. So we can say this is the same thing as 3 into 1 minus cos square theta minus 2 cos theta minus 3 equals 0. What we've done here is we've put sine square theta equal to 1 minus cos square theta. In place of sine square, we have put 1 minus cos square. And now we have only one function. Now we have only cos. We've gotten rid of the sine there. Let's simplify this. This gives us 3 minus 3 cos square theta minus 2 cos theta minus 3 equals 0. If we were to simplify this, this becomes minus 3 cos square theta minus 2 cos theta equals 0. 3 and 3 get cancelled. Now we can get rid of the negative sign as well. That gives us this. What do we do now? How do we solve this further? क्या करें? Anyone? We haven't done that. So yeah. You can take the cos theta common. You can bring cos theta outside here. This becomes 3 cos theta plus 2. Then you have 0 on the other side. Iman, you went out during the middle या फिर अभी आई हैं आप? Okay. Cos theta into 3 cos theta plus 2 equals 0. That means either cos theta equals 0 or 3 cos theta plus 2 equals 0. Because if the product is 0, that means at least one of them has to be equal to 0. So we have either cos theta equal to 0 or cos theta equal to minus 2 over 3. Now we solve these two equations one by one. Let's solve the second one first. How do we solve this? सबसे पहले क्या करेंगे? Basic angle. So we say cos alpha equals 2 over 3. Replace this angle with alpha. Make the negative sign positive. Right side को positive कर दें. And now find the basic angle. Angle is in degrees. Degrees में देखें आपके पास क्या आता है. What's this? Alpha? 48.19. 48.19. So this is the basic angle that we're getting. Now we draw these quadrants. Cos is negative. Negative कहाँ पर होता है cos? A, S, T, C. Which quadrants can we be in? Second and third. First में cos positive है, second में negative है, और third में negative है. All right, so we only consider the second quadrant and this quadrant. So this is 48.2 here. Let me just write alpha. You have one basic angle here and one basic angle here. What are the values of theta then? अच्छा अभी यहाँ पे एक मिनट देखें. Your cos is negative in the second and third quadrants. So we could have an angle in the second or third, but there's another limitation. And that is that theta can only be between 0 and 180 degrees. Okay? Now, if you were to go to the third quadrant, उसमें theta क्या होएगा? It will be greater than 180. So we can also have to exclude the third quadrant from this because that's outside the range. Range से बाहर है, इसलिए आपको वो भी exclude करना पड़ेगा. So we have only one possibility, and that is this angle here. This is going to be 180 minus 48.19, and that turns out to be 131.8 degrees. This is one value of theta that we are getting. Okay. Let's solve the other part of this equation now, which is cos theta equal to 0. How do we solve this equation? Can we use the quadrant method here? That doesn't work, right? Quadrant method यहाँ पे नहीं चलेगा. तो क्या करेंगे फिर हम? 90 के multiple check कर ले 0 और 180 के दरम्यान में. Check 0, check 90 and 180 and see which one of them satisfies. 0 would not, 90 will satisfy, 180 would also not satisfy. So you'll get one answer from here, which is 90 degrees. ये आप डायरेक्टली बस आंसर लिख देंगे यहाँ पे. So you've got two values of theta that work, 90 degrees and 131.8 degrees. These are the two answers that we've got. Any problems? Any questions on this? No? Now you have to attempt the assigned questions from the worksheet. You have 2 days. Please make sure that you try as many as you can. Friday ko we will only be doing practice questions. Okay? हम worksheet से questions करेंगे sir. All right? Let me mark your attendance and then you can leave. Just give me 1 minute. Adina Mohid, Ayman Masood,